Welcome back, chemistry students, to our Chapter 2 video notes that's going to cover molecular and ionic substances. This set of video notes is a precursor to learning how to name substances. So it's going to be talking about all the things that we need to know in order to begin the naming process, which is going to be a huge part of chemistry. So let's review a couple of things that just to make sure that we know it all. So when we look at chemicals, you are going to see chemical symbols and subscripts be used to express what types of elements are in a compound. So there are different classifications of compounds, which are going to be shown here. So there's molecular compounds, which are also called covalent compounds. And the key with these is that they are sharing their electrons. We're going to get a lot more into the whole idea of sharing electrons later on, but right now, something like water would be a chemical that you would classify as a molecular or a covalent compound. And we'll get to how to classify them a little bit later. So the other thing that you need to know is about ionic compounds. Ionic compounds are formed when electrons are transferred between elements to form something called ions. Ions are just charged particles. So they are atoms that have an unequal distribution of protons versus electrons. And then there's two other ones that might be new to you. The diatomic elements are elements that exist in pairs. What I mean by this is sometimes when you might hear us talking about like oxygen gas, you know, the oxygen in the air you breathe, oxygen is O2. So this 2 right here means that oxygens are going to travel in sets. So if we were to kind of draw this pictorially, we would draw, that's not meant to be an oxygen, that's meant to be a circle for an atom. We would draw 2 atoms connected together, and that would be our little pair of atoms that are traveling as a set. They do this because they're not stable on their own, and so on our Earth, in our atmosphere, right, the air we breathe, we're going to see 7 elements exist as diatomic ones. Eventually, you'll have those 7 memorized. Let's see if I can do them off the top of my head. It is hydrogen, nitrogen, oxygen, chlorine, fluorine. Oops, oh my goodness, I just made a huge baby chemist level mistake. Fluorine is F, not FL. Chlorine, fluorine, iodine, and bromine. So I probably didn't do them in the order I wanted, but they're all there. And then hydrates are our last classification, and these are very interesting. These are ionic compounds that have water stuck in between the ions. So ions with water molecules stuck between the ions. So the hydrates are going to look a little bit different than your other types of chemical compounds because they are going to have this little dot in between them. So this one right here, magnesium sulfate dot 7 H2Os, that is actually Epsom salts in real life. So you're saying that for every magnesium sulfate pair, you have 7 water molecules. So let's talk about how these ratios or these subscripts are communicated and what they mean. So we said that this little 2 means that you have 2 nitrogens traveling as a pair. Over here, this 2 in the H2O means that you have 2 hydrogens for every 1 oxygen because there's not a 1 drawn here at the end of the oxygen, but it's assumed. Then if we look at hydrates, your magnesium, you only have 1. Your sulfur, you have 1. That oxygen has the 4 subscript that means that you have 4 oxygens. And then when we look at hydrates and we see this 7H2O, that 7 is like kind of math class, right? Where that 7 gets distributed to the 2 and also to the invisible 1 for the oxygen. So you have 14H and 7 oxygen there. And then the last one is a little on the tricky side. So you have to kind of think, does the 4 for the hydrogen and the 3 on the outside, do you add those or do you multiply those? So let's talk about what this means. The NH4 is something we're going to learn as a polyatomic ion. It's called ammonium. And ammonium has 1 nitrogen to every 4 hydrogens. Then when you have this parentheses here and the 3 on the outside, that 3 means you have 3 ammonias. So that 3 also gets distributed. So you have 3 nitrogen, you have 12 hydrogen, and then for the PO4, there's an invisible 1 that's written, well, not written, for the phosphorus, and then you have 4 oxygen. So we just want to be able to kind of figure out the quantity of the elements that are present based upon the chemical formula. So let's keep going. Let's talk a little bit about how compounds look at a molecular level. If we start looking at molecular compounds first, molecular compounds are going to share their electrons, right? So maybe you're talking about something like H2O. Pretend the circle I just drew is oxygen. Then when you see this, you're going to see your hydrogens drawn as circles themselves, and they are going to be connected to the oxygen. And that fact that those circles are drawn in a touching fashion means that they're chemically bound together. Whereas for an ionic compound, because we ended up having a transfer of electrons to create ions, one ion will be positive, one ion will be negative, and positives and negatives are attracted to each other. So maybe you have a negative ion that then is just sitting next to a positive ion, which is sitting next to a negative ion, which is sitting next to a positive ion, and so on and so on. And this pattern just continues to repeat over and over again until you create something called a crystal lattice. We'll worry about that terminology of crystal lattice later on. But for right now, we just want to have a kind of pictorial version of what these things look like. So some terminology. When we look at molecular compounds, your molecular compounds have molecules, like this one I just boxed. Molecules are discrete units. Let's think about if you know what discrete means. So discrete would mean that it's its own entity, right? It is these 3 atoms bound together. That is one water molecule. Whereas your formula units is actually the smallest whole number ratio between ions in an ionic compound. Most students do well with molecule, right? This. And then when they see formula unit, they are like, I don't know what you're talking about. So let's go back to this picture of an ionic compound. Pretend this is sodium chloride. The chemical formula for sodium chloride is NaCl. And so in this picture, I have a Cl and Na, a Cl and Na, a Cl and Na, and so on and so on. So I have lots of Nas and Cls in here, but if I look at the ratio between Na and Cl, I should end up with a 1-to-1 ratio, which is what you're describing in the chemical formula. So it's almost like you're reducing a ratio from a you know, an Na20 to Cl20 can be reduced to an Na to 1Cl. So we're going to keep working on that as time goes along and we start learning some more stuff. Let's continue looking at the things that we need to learn how to name things. So when we come to class next, we are going to want to know on the periodic table which columns form particular ions. So part of this you might have seen in a previous chemistry class, and part of this you might have no idea where these numbers are coming from. So we'll worry about where the numbers are coming from when we're in class, but right now know that the first column always forms a 2 plus or a 1 plus, and you know what, I'm actually going to write the plus on the other side for clarity later on. So a 1 plus and a 2 plus charge. The stuff in the middle, all of this, that does weird things. Even some of the things over here do weird things. And we don't really care about the lanthanides and actinides because they often are not seen in the ionic compounds that we're concerned with. And then in this column, we really care about aluminum, and aluminum does a 3 plus. Some of the other columns or items in that column might also do a 3 plus, but they're a little bit rarer, so we're not going to concern ourselves with them. You might have learned in your chemistry class that this column is a +4 or a -4, and I really dislike that because I am an organic chemist and this is where carbon lives, and guess what? Carbon doesn't do a +4 -4. Carbon makes covalent bonds. So let's not concern ourselves with this column. So this is like our reset column. Once we get to this reset column, notice how we were going up from 1 to 2, skip this part, 3, and they were all positives. Now we hit the carbon column and it's our reset column. So now we're going to go to 3, but negative, 2 negative, 1 negative, and over here are our noble gases. And those aren't going to form ions. So in class, we are going to want to utilize these charges, so make sure you have those handy. So let's talk about classifying compounds, because if we can't classify them, we can't name them. So we're going to start with the most basic classification for ionic compounds. In general, your ionic compounds are going to contain a metal and a nonmetal. This is the most basic definition, and we are going to expand upon that as time goes on. So by the time you take the first exam, this will be 1/4 of your ionic compound definition. So we're just going to start here, we'll build on it. Molecular or covalent compounds are 2 or more nonmetals. So you might be thinking, well, goodness, I am going to have a problem with this if I don't know what part of the periodic table has the metals and which part has the nonmetals. And if you are thinking that, then you might go into the review packet that I gave you last class so that you can look through and start to figure out a little bit about the periodic table. One of your past videos should have discussed where on the periodic table are the metals and where are the nonmetals. So in addition to classifying just with ionic and molecular, we're going to continue to further classify. We're going to take your ionic compounds and we're going to further classify them from ionic to binary ionic and ternary ionic. So with our binary ionic compounds, bi means 2, and so this is going to have 2 elements in it. And really they're ions, right? But, you know, we'll get there. Whereas ternary will have 3 elements. And you don't know yet, but it still only contains 2 ions, even though there's 3 elements present. We'll expand upon that when the time is right. For molecular compounds, notice how molecular compounds only have the option of binary. And then here's one that we didn't talk about on the top or the bottom of the previous page, was acids. In our general chemistry class, we are going to keep acids as basic as we can. And we're going to say that if a compound starts with the letter H, has some elements afterward, and then ends with AQ, which means dissolved in water, aqueous or aqueous. Those are the two ways to pronounce what AQ stands for. Then it's going to be an acid. Same thing here. You start with H. There's going to be some elements that come after that. You end with AQ. That's going to be your kind of trigger to know that you're talking about an acid. Something that's binary is only going to have the hydrogen and one other thing here. Something that's ternary is going to have the hydrogen and two other elements here. So let's pull out an example of each in this table down here, and then you can practice filling in the rest of the table. So calcium oxide. Is calcium a metal or a nonmetal? So hopefully you pulled out your periodic table and you recognize that calcium is a metal. If calcium is a metal, then automatically we're talking about ionics. And then we have a nonmetal with it and only one nonmetal. So this is ionic and binary. Let's look at the next one. Hydrofluoric acid. Hydrofluoric acid is starting with that H and ending with the AQ. There's only one other element besides the H, which means you have a total of two types of elements, which means it's binary. So it's an acid that's binary. Let's look at this next one. Silver chromate. Silver chromate now has a metal, silver, so you know you're talking about ionics. So you're into these first two columns. But notice how now you have 1, 2, 3, right? Silver, chromium, oxygen, 3 different types of elements. So that means we're looking at a ternary ionic. If we look at the next one, carbon disulphide, look at your periodic table and see where carbon is. Carbon's a nonmetal, and so is sulfur. So there's no hydrogen in there, so it's definitely not an acid. There's no metal in there, so it's definitely not ionic. So what we have left is molecular. Let's sneak down to the second from the bottom, the nitric acid. Nitric acid has the H out in front, the AQ at the end, and then it has a total of 3 types of elements present. This is an example of a ternary acid. Again, when we start naming, we need to first know how to classify things. Because if we can't classify them, then we don't know what naming system to use for them. Because unfortunately, there are about 5 different naming systems that we're going to learn, and they're all very intertwined. So practice finishing this table and filling it out so that you can classify things. We have one more set to classify, and that's down here on our final page. So in addition to classifying compounds, something that's going to become really important is to classify ions. So this is going to be a super brief overview as to what a polyatomic ion is, and we're going to spend more time in class doing it. So up here at the top, we see that we have ions, and then we see in our flowchart that ions can be classified into 2 main groups. Cations are positive ions, anions are negative ions. So then we start looking at the cation section. Notice how there is this mon, right? Monatomic and polyatomic. So mon is part of the abbreviation of mono, and mono means 1. So monatomic is 1 atom ions. Polyatomic is many atom ions. So let's look at some examples. Monatomic cation. Here we are, Na+. Plus means it's a cation. There's only one type of atom in there, and it's a sodium. So it's a monatomic. Whereas if we look at NH4 plus, still plus, so still a cation, now we have nitrogen and we have hydrogen. And so we have more than one atom in our ion. And so this would be a polyatomic ion. Then the same thing is going to hold true for the anion side of things. We have negative ions now, and so now in our monatomic, we have single atom ions that are negative, polyatomic, multi-atom ions that are negative. So let's practice classifying a couple of these. O2 minus, is it positive or negative? Once you recognize it's negative, come back up here and say it's an anion. Because it only has one type of atom present, it's a monatomic anion. Na plus, Na is a singular atom, plus is a cation, it's a monatomic cation. Then we have CrO4 2 plus. We see that it's plus, so we know we're talking about cations. Notice how now we have more than one type of atom present. So this is a polyatomic cation. Let's skip down here to this one, iodate, IO3 minus. You have a negative ion. You have more than one type of atom present. So this is a polyatomic anion. So before you come to your next class, ideally what you're going to do is look at your periodic table and figure out where the metals are and where the nonmetals are. You're going to look on Desire to Learn, and on Desire to Learn, there is a periodic table on there that has some boxes highlighted, and these are the elements that you have to know their names. So I think it's called Periodic Table Names to Know. So you're going to start working on knowing those names. And then finally, you are going to, oh, what was the other one? Trying to remember now. I thought there was a third one. Well, let's just say be prepared to memorize the polyatomic ions. And I bet you the polyatomic ion sheet is posted on Desire to Learn if you want to get a head start. So, as always, thank you for watching, and I will see you in class soon. Katoni signing out.